part of this. Okay. All right. Let's have a look at last day, right? We talked about timelines, right? How to properly construct a timeline. And then we talked about, okay, well, how do we find principal amounts and how do we find future values for simple interest problems? And then we also solved for the interest rate and time, right? And so just as a little review, bless you, we looked at timelines last day, right? And so timelines just organize the question and it organizes what we're about to do. And everything from the question should be communicated on your timeline, right? And so usually I have a pretty good idea of how you're going to do on a question just looking at your timeline. If you have a solid timeline, then usually there's no way that you can screw it up later, right? So you really want to focus and work on your timelines. And remember that the principal goes to a future value, or we can go from a future value to a principal amount, right? But regardless, the P is always on the left and the future value is always on the right. So always on the left and always on the right. That's going to be important to keep in mind for when we solve future problems, right? Because whichever way we find ourselves drawing this arrow, that's going to tell us what we have to calculate, right? It's a principal amount or a future value. And then we calculated R and T. And then we started example 161. So what I want to do is, you've got it already, right? But let's just work through it as kind of a review. Right, we did the timeline last day, but it does not hurt to do another timeline. And then the actual solving of the problem, I encouraged you to go home and work through it on your own. But it was Thursday afternoon, so probably, I'm guessing it didn't happen. So, but if it did, then that's even better. Okay. All right, so we were working on this problem, right? And remember, for timelines, the first thing you're going to do is you're going to read the problem and you're going to identify how many dates we're talking about, right? And so we're going to read this problem. So calculate the fair market value. So what is the value of the scheduled payments 60 days from now? So what's the value of all these payments 60 days from now, right? So we're talking about today, 60 days from today. So already we've seen 2 dates. If money can earn 8.5% payments of $1,000 today, I've already taken care of today, right? 1,570 days, so that's another date. And then $2,000 in 210 days, right? So I've got 4 dates that I need to put on my timeline, right? So that's always where you're going to start. Just figure out how many dates you're dealing with and then draw your timeline. And I don't bother with proper spacing. I just do equal spacing between all these dates, or roughly equal, because it's more of a visualization, right? It doesn't have to be a timeline to scale. Okay. So as far as these dates go, so now remember the second step is to put the dates over top of these ticks, right? And so we've got the first date in order is today. And then we had 60 days from today. We had another tick at 70 days from today. And then the last tick at 210 days from today. Okay. So far, so good. Next thing we do is we put any dollar amounts underneath our ticks, right? So any dollar amounts that are associated with that tick goes underneath. So we've got $1,000 today, 1,500 in 70 days. So 1,500 goes there at 70 days, and then 2,000 in 210 days. What I want to highlight here is calculate the fair market value of these payments 60 days from now. And so here, calculate the fair market value 60 days from now. So the focal date is at 60 days, right? Because we want to know what's the value 60 days from now, which means we're going to pull all these payments to 60 days. And so I'll put a little arrow here. The focal date is where we draw all our payments to, right? So that's where all our arrows are going to end up. Which means that the payment today gets pulled forward, right? And then the other two payments get pulled backwards. The sum of all those at 60 days, that's the total value at that point. So I can't remember, the fourth step, I guess, is to draw these arrows, right? You want to make sure that it looks pretty tidy. It doesn't really matter, but I like to work from as close to the focal date as possible, and then I draw my arrows moving out, right? Because then there's less overlap. Sometimes it's unavoidable, but usually it works out pretty nicely. So if I start from today, I pull it to 60 days, and at 60 days, it'll be worth some future value, right? Remembering that if you're pulling your arrow forwards, you're calculating a future value there. This 1,500 at 70 days has to get pulled backwards, and I give it its own line. Oh, it changed to a circle. There. Because I'm pulling it backwards, I'm calculating P. Same thing for the 2,000. It's also going to be pulled back to a P. If I add these, right, this is the fair market value. I shouldn't have said total there, because the question says fair market value 60 days from now. So the total is going to be the fair market value 60 days from now. Notice that we've got two P's and they're not going to be the same, right? And I'm also calculating the future value. We could just put subscripts on the P's, and I can't remember if we only put subscripts on the P's last day. But what I'm going to do is I'm going to put subscripts on all of these, and the subscripts are going to denote the order that I'm going to do these calculations in. Right? In this case, it doesn't matter which one I calculate first, second, or third, right? But sometimes it will matter, right? And so here, I'm going to use future value 1, P2, and P3. And I'll make a note below here. I use subscripts to denote the order of my calculations. I suspect maybe last day we didn't put a subscript on the future value, but it's good to get in the habit of just putting subscripts on all of them. All right. Can't remember what step we're on, but the next step is to put how much time each arrow is worth, right? And so this arrow, this first arrow, we can call it T1 because it goes with my first calculation, is going to be from today to 60 days. Because we're talking days, right? Time, T, always has to be in years, right? So we're going to have T is 60 over 365. So it's 60 over 365. Same idea for the next arrow, but we have to be careful, right? T2, because it goes with our second calculation. This is the one that caught me last day, right? Because I was getting sloppy and I said 70, but it's actually the distance between 60 days and 70 days. That's only 10 days, right? And so 10 over 365. And then finally, T3 is the distance between 60 days and 210 days, which turns out to be 150 days. And then the last step for our complete timeline is to put the rate somewhere along here, right? Because the rate is the same for all these all along, and we have a rate of 0.085, right, or 8.5%. So here, this is our complete timeline. As you can probably tell, if I'm marking a test and I see something like this, and it's all organized and it looks like you've identified all these things like the time and the rate and the future values and the present or the principal amounts that you have to calculate, right? I'm pretty confident that once you have it laid out like this, then doing the calculations is not that bad, right? And then, because now you've got a roadmap. So now, I guess this is the new stuff for today. We didn't do any calculations, right? But now we're ready to do the calculations. And I'm going to do them in the order that the subscripts are. You can do them in any order, doesn't matter. So future value 1 is, let's see if I forgot to mention anything. No. P times 1 plus R times T. T1 in this case. The principal amount for future value 1 was 1,000. Times 1 plus R, which was 0.085, times T, T1, which was 60 over 365. Order of operations, right? You have to be really careful that you take 60 over 365 times 0.085 and then add it to 1, right? So you have to do that multiplication and division inside those brackets before you can move on to the addition, right? And so to show that or to emphasize that, I'm going to simplify the 0.085 times 60 over 365, 0.085 times 60 over 365 is 1 plus 0.01397, so 9972603. Oh. Now I've got 1,000 times 1.013972603. So just add 1 on your calculator and then multiply it by 1,000. We get 1,013.972603. The future value 1 as a dollar amount is 1,013.97. What's that saying? It's saying that if I had promised to pay you $1,000 today and you charge a rate of 8.5%, and I say, hey, I'm not going to pay you that back today, can I pay you back in 60 days? You're going to say, sure, but you're going to owe me $1,013.97 then, right? So that's how money works, right? You're not just going to owe $1,000 60 days from now. You're going to owe $1,000 plus interest, right? And so we have to take that into account. Here, what's happening here is I said, oh, I said I would pay you back in 10 days from now, right? But how about I just pay it all back, well, 10 and 150 days from now, right? How about I just pay it all back, right? I know I owed you some money from 60 days ago, right? If we're talking from the focal date, right, then I owed you some money that I didn't pay you, so I have to pay interest on that. But then I'm kind of prepaying these, so I don't have to pay as much, right? Because you have to give me back that interest that I was supposed to be paying, right? So future value 1 is $1,013.97. How about P2? Let's just, because we're about to use the P formula twice, right? Let's just see how we get it. It's nothing crazy. Future value is P times 1 plus RT. And so solving for P, we get the future value over 1 plus RT. Only because I'm about to use it twice, right? So it's nice to have just the formula to plug things into, right? Because now I can say P2 is the future value of P2 over 1 plus R times T2, if we want to be specific. The future value, right, so the amount on the right-hand side of the arrow for P2 was $1,500. So we've got 1,500 over 1 plus R, which is still 0.085, times T2, which we said was 10 over 365. So we've got 10 over 365, because what I want to do is I want to simplify the 0.085 times 10 over 365 into one number before I add it to 1. Very important. You could try not doing that, but you'll get a way wrong answer. 0.085 times 10 divided by 365, and then we get 1,500 divided by plus 1. 1.0023, oops, 28767. 1,500 divided by the previous answer equals, good, 1,496.514965. In money, P2, oops, P2 is 1,496.51. All right. So instead of paying back $1,500, if I pay it back 10 days early, then I only have to pay $1,496.51. Same deal for P3 is the future value over 1 plus R times T3. The future value for P3, right, was $2,000 over 1 plus, the rate is still 0.085, times T3, which was 150 over 365. .085 times 150 divided by 365 plus 1. I get 2,000 divided by 1.034931507. 2,000 divided by previous answer. You guys know the previous answer shortcut on your calculator, right? If you go the second function and then equals, there's A and S over top of the equals, right? And so what it'll do is it'll just put in the most recent answer that it gave you, right? So I use that a lot. So I get 1,932.49536, or in money we get P3 1,932, 49.5 rounds up to 50. So the fair market value 60 days from now is the same as the total, which is going to be future value 1 plus present or principal amount 2 plus principal amount 3, which we found was 1,013.97 plus 1,496.51 plus 1,932.50. Which if we add these all up, we get $4,442.98. So instead of paying $1,000 today, $1,500 70 days from today, and $2,000 210 days from today, I could pay $4,442.98 60 days from today, and they would be equivalent. Right. Any questions about that one? All right, let's do another example. Example 163. No. This one's brand new. And 60, I hope. 210 minus 60. That's right. because as a rule, the length of the arrow is the distance, right? And so from 210 days to 60 days is 150 days. Good. Okay. So we're gonna step it up a notch here. Now we've got two different interest rates, and that's gonna be the trickiest thing to deal with, right? Otherwise, everything stays the same. So we just have to approach it methodically with our timeline. So 4 months ago, right? So 4 months from or before today, I guess. Teresa borrowed $1,000 from Josh and agreed to repay the loan in 2 payments to be made 5 and 10 months after the date of the agreement. Yeah. And so that was, the date of the agreement was 4 months ago. Or was it? Yeah. Sorry. Each payment is to consist of $500 of principal and interest at a rate of 9% on that $500 from the date of the agreement. Today, Teresa is asking Josh to accept a single payment 3 months from now to settle the debt. What payment should Josh require if money can now earn 7%? Right, so we've got a first agreement and then a second agreement where she's like, oh no, I changed my mind. I'm just gonna settle it up now. But the interest rate changed in that time. All right, so we need to keep our wits about us. First thing we do is we need to figure out how many dates we're dealing with, right? And so if we read this, so we've got 4 months ago, but as like a kind of a gauge, right? We need to have today on there so that we can mark today and then 4 months from today, right? But the 4 months ago is the agreement date. And so this here, 4 months ago, this is the agreement date. So we've got 4 months ago from today, so we've got to put today on there, even if there's nothing really happening there. Teresa borrowed some money, and she's going to make payments 5 and 10 months after 4 months ago. Right? So far, I've got 4 dates. Right? And so each payment is to consist of $500 of principal and interest at the rate of 9%, blah, blah, blah. Today, okay, so today's already on here, so we don't have to put it on there again. But Teresa's asking Josh to accept a single payment 3 months from now, which is another tick on there. Right? It could end up being one of the ticks that we have, right? Because we're talking about from today, 5 months from the agreement date, and then I think, 7, 10 months from the agreement date, but it actually ends up being another tick. It's a good idea to kind of list these dates on the side and get those sorted out in your head, because once you have the dates all figured out and sorted, then the timeline is going to run smoother. Right? And so, because for me, right, when I do it, it's like, oh yeah, that sounds reasonable. 5 dates, sure, great. But it's hard to read this and figure out that you need 5 ticks, right? That's a tough start. So whatever you have to do to kind of figure out how many ticks you need, just do it. Yeah. So I need 5 ticks. So I'm just going to put them on here equally, kind of, or try to equally space them out. I'm going to give myself a little bit more room, actually, over on this end. I don't know if anything changed, but. Okay. So if we had a list of all our dates and we were able to organize them, right? You might organize them as 4 months ago and then today, and then you could talk about the 5 months from the agreement date, but because we've got today on there, I think most of our brains just kind of want to talk in terms of today, right? So if today you're looking, you've got 4 months ago and 1 month from now, right? But what we've got is we've got 4 months ago. And then we've got today on here. The next tick is going to be the 5 months from the agreement date. Right? 5 months from 4 months ago is only 1 month from today. Right? So 1 month is what I'm going to put here. Okay. But then over top, I'm going to put 5 months. Oops, 5 months. 5 months from agreement date. Right, and then the 4 months, this is the agreement date. The agreement date is just whenever you borrowed money, you agree to pay it back at some point, right? So that's the agreement date. So then she rejigged, so we're at today now, and then she says, hey, can I just pay you back 3 months from now with one payment? Right, and so 3 months from today, that's when she's going to pay this all back, right? And then the last date is 10 months after 4 months ago, right? 10 minus 4, that's 6 months. Oops. 6 months, but I'll just clarify here that that's 10 months from the agreement date. That doesn't say agreement. Okay. So those are tricky. Okay. So whatever you have to do to kind of untangle those dates. But now that we have them, right, and we can kind of double check that they are in order, right? Now we can start putting dollar amounts under these dates. It's not going to look the same way that it did before, right? Because now, so she borrowed $1,000. But then what they decided was, okay, I'm going to pay back 500 of that plus interest, 5 months from the agreement date. And then the other 500 of that plus interest, 10 months from the agreement date. Right? And so what we have is we actually have $500 and $500. The sum is the $1,000 borrowed.
How we put the 3 months with the 6 months if she had us 10 months agreement, and then she asked for the 3 months.
But it's because it says, so today, Teresa's asking Josh to accept a single payment 3 months from today, right? And so the 4 months ago, they shook hands and they said, yeah, I'll pay back half of this plus interest in 5 months and then the other half in 10 months, right? And so the original agreement doesn't care about today or the 3 months, right? And so, sorry, I can't see, I'm not like stirring, I'm like trying to see. Right, and so the original agreement, you really don't need this or this on there. Right? You only need the agreement date, and then you could say 5 months and 10 months. Right? But then, because we're talking about, okay, well, today they made a new agreement, right, and said, well, what I'm going to do is from today, I want to just pay it all back in 3 months from today, right? And so we've got these, the original payment plan, which says these two, I'm going to pay back here and here, right? With interest, right, respectively. More interest on this one than this one, right, because it has to go further. But then what she's saying is, okay, no. Today, she says, actually, you know what? I'm going to pay these back. So instead of paying back here and here, I'm going to pay these both back 3 months from today. And so that's how we're going to do these calculations, right? So, all right. So like I just showed, this 500 gets pulled forward to a future value, right? Because we're pulling it forward, so it becomes a future value. Let's call it future value 1. This other $500 gets pulled forward to some future value 2. That's the original payment scheme, right? She's going to pay back future value 1, 5 months from the agreement date, and then future value 2, 10 months from the agreement date. Right? But then she changed her mind. And she said, well, instead of doing that, what I'm going to do is I'm going to pay you back 3 months from today. All of it. Okay? But before we do that, what I want to do is I want to put T's on these arrows, just so we don't forget to do that, right? Because I want to treat them as kind of 2 separate things. So time for this first one is the distance of this arrow is 5 months, right? So 5 over 12 in terms of years. So 5 over 12. T2 is 10 months, right? The distance of this arrow is 10 months, so 10 over 12. An added thing that we had to keep track of, and this is the reason that I wanted to put the time on these arrows right away, is that the rate changed, right? So the rate for these 2 original arrows had a rate of what? 9%. Right? So what I'm going to do is I'm just going to jot down that the rate for these arrows is 0.09. We could even call them R1 and R2 if we want to. Really try to keep each arrow separate. Okay. So then I'll pick a different color, right? Because this is and I'll underline the colors that I used for each agreement. So then today, Teresa is asking Josh to accept a single payment. So now, after we've calculated these amounts, then what we're saying is, okay, well then we want to know what's the value of these amounts 3 months from today, right? And so that makes the 3 months, that's our focal date, right? Because that's where we're pulling all our payments to. So here, this is our focal date. Some people find the focal date helpful, some people don't, right? But the focal date, I just highlight it because it's where we're pulling all our payments to the end. So this is where it gets weird, and this is where the order that you do these calculations starts to matter, right? Because you can't pull the future value forward 3 months, or I guess 2 months, 3 months, without knowing what it is, right? And so what we take, is we take this future value 1, once we've calculated it, and we calculate future value 2 later, so this was going to be our future value 3. And future value 2 is going to get discounted, bless you, to P4, right? Because it's getting pulled backwards, so it's going to be a principal amount. If we add these up, this is the total owing. Total owing 3 months from today. We're going to do the same thing. We're going to find T for each of these arrows, but also we're going to jot down that the rate is now 7%, right, for these new arrows. And so we've got T for this one, and it's another trickster, right, because the arrow is going from 1 month to 3 months, so the distance there is only 2 months, right? So 2 over 12, and the rate is 0.07, right, for 7%. For this last arrow, right, it's the distance between 3 months and 6 months, which is 3 months. And so we've got T, and I could even do, I didn't do subscripts, but you know what I will, T3, R3, T4 is 3 out of 12 months, and R4 is 0.07. The R's don't really need subscripts, but I don't know, they help. Maybe. So this is our complete timeline. This is all the information that the question gave us, all shown kind of visually, right, with a roadmap of how we're going to do these calculations. All right, and because we've got the rates on each of the arrows, then we don't have to write the rate anywhere because it's changing, so we have to keep track of that. All right. Any questions before we do our calculations? All right. So we first need to find future value 1 and future value 2. So future value 1 is P times 1 plus R times T, R1 and T1, P1 technically. P for each of these original payments, right, is going to be 500 times 1 plus R, which was 0.09, I'm going to say 9, right? Yeah, times T1, which we said was 5 over 12. So we've got 0.09 times 5 over 12, and then plus 1. I get 500 times 1.0375. And times, 500. Hey, nice, it's already to 2 decimal places, 518.75. Same thing for future value 2 is P times 1 plus R2T2. P was again 500 times 1 plus R, which is 0.09. And then T2 was 10 over 12. .09 times 10 over 12 plus 1 is 500 times 1.075 times 500, 537.50. Adding the 0 because we are talking money, and so we always want to have 2 decimal places. Bless you. Okay, right. So the original agreement said, hey, in 5 months, I'm going to pay you back $518.75. And then in 10 months, I'm going to pay you back $537.50. And then we're even, right? But then she's saying, hey, let's rejig that, right? And so now we can calculate now. Oh, you know what? I'm going to change the color just to match. Now we can calculate the new agreement by finding future value 3 and P4. Just hearing things. Okay. All right, maybe I can do a little darker green. Technically, right, future value 3 has a principal amount of future value 1. Right? And so what we do is we can find future value 3 is P times 1 plus R times T. Right? Which is future value 1, right? The P for this guy is future value 1 if you want to use notation, right? Times 1 plus R3 T3. Or if you wanted to just use the values right away, 518.75, that's fine too, right? But I just want you to see what's happening. 518.75 times 1 plus R now is 0.07 times 2 over 12. 0.07 times 2 over 12 plus 1, oops, I mucked that up. 0.07 times 2 over 12 plus 1. 518.75 times 1.01166 repeating times 518.75 I get 524.8020833, which in money is $524.80. All right. So what's that saying? That instead of paying $518.75 5 months from the agreement date, she's going to pay $524.80 3 months from today, right? Depending on how you want to think of those dates. Right? And P4 is a future value over 1 plus RT. The future value is a future value that we calculated already. It's future value 2 over 1 plus R4 over or times T4. Future value 2 was 537.50 over 1 plus 0.07, right? Want to keep track of those rates, times T4, which was 3 over 12. $537.50 over 0.07 times 3 over 12 plus 1 over 1.0175. 537.50 divided by 1.0175. I get 528.2555.283. In money, 528.26.
Are there any questions that can help us with getting the timeline down better?
All the practice problems. And there's a lot of examples that I'm not doing. And so those are helpful because then like usually they'll show the timeline, but if you try it on your own, right, then you can kind of check to make sure that you've got all the components because they are tricky. So then the total value, right, so the total owing 3 months from today is future value 3 plus principal 4. So total owing 3 months from today the total is future value 3 plus principal 4, which is $524.80 plus $528.26, which is $1,053.06. Oops. In money. Oof. It's a biggie.
So was that starting on compound? Or was that...
No, we haven't started compound interest. This is still simple interest. Just itty bitty simple interest. Nothing to see here. No, but the timeline skills, they're nice to work on in simple interest, right? And have these kind of big, massive problems for simple interest. because there's less going on for simple interest, and then we have to do a little bit more for compound interest, which we should be starting today. So we'll see. We'll see how we do. All right. Any questions about that one? So what I want to do is I want to do example 165 because it's a different type of problem where we have to find the amounts, right? And especially we want to have equivalent payments, right? And so example 165. And you know what? I'm going to make a little note here first. Some problems will require that we find equivalent payments. Equivalent payments, right? Or unknown payments. What keeps jumping around on me? So here's an example of what I mean. We're still going to do a timeline, right? But I'll show you how we approach it a little bit differently, because now we don't have any amounts and we're going to try to solve for them. So a loan of $10,000 requires 3 equal payments to repay the debt. The first payment is after 6 months, the second payment after 1 year, and the third after 1.5 years. What is the amount of the payments? Use today as the focal date and assume a rate of interest of 6%. Okay. So same deal, right? We're going to read the blurb and we're going to try to figure out how many dates are we talking about, right? And so we've got the first payment 6 months, but 6 months from today, right? And so we have to have today and 6 months, and then another payment at a year, and a last payment at 1.5 years, right? So we've got 4 dates that we have to deal with. So that's where I'm going to start here and draw 4 ticks. I'm going to put the dates up above, so today, and then 6 months from today, 1 year from today, and 1.5 years from today. Well, it says years, but it doesn't look like it. Oh. And you'll sometimes see this, right? If you, oh yeah, pay it back in 3 easy payments. They're always easy payments somehow. Like 4 easy payments of this much, right? And things like buying a car, if you're financing a car or a mortgage, there are more advanced versions of this, right? Because now we're only talking about 3 equal payments, right? A car, you have to pay more payments. Mortgage, definitely you have to pay more payments than 3, right? But it's the same idea because the payments are equal, right? But what's happened, right, is I borrowed $10,000 here today, right? And then I'm splitting it up, right? But here, 6 months, I have to pay less interest on the 6-month payment than I do on the 1-year payment and the 1.5-year payment, right? And because I borrowed that amount for longer, right? And so, but we want to make these equal because otherwise it's really hard to communicate to a client, for example, oh, well, 6 months from now, okay, you're going to pay back $120, and then a year from now, you're going to pay back $127.50, and then a year and a half from now, you're going to pay back $131. That makes sense, right? No, it doesn't. So that's why we want to have equal payments so that it's easier to talk about, right? But those equal payments are taking into account the different interests that we have to pay. Okay? So to denote these equal payments, what I'm going to do is I'm going to just put X underneath here. Okay? X let X denote the unknown payment amount. Okay. We can still work with X, and what we'll eventually be able to do is we'll be able to solve for X. Okay. All right. So this first X, right, at 6 months, because I was told to use today as the focal date, which you would have done anyways because you know what these payments all have to be worth $10,000 today, right? So you would have had to pull them back here anyways. The question telling you to use today as a focal date is just a hint, right? To pull all those payments back to today. So, all right. So what do we have going on here? So this first X at 6 months is going to get pulled back to some principal amount 1. We don't know what it is, but we'll be able to use it. The second X at 1 year from now gets pulled back to some P2, right? Remember, I'm pulling these arrows backwards, and so I'm going to be calculating P is at the end. And same thing with this last X. Also getting pulled back to a P3. Now, what we do know is that the sum of all these, right, add these all up, has to be the $10,000 that I borrowed. Okay. Even though it looks like I haven't filled out my timeline, that's all I know. I know I have X as my unknown payment amount, and that's going to get pulled back to P's, right? But I can start putting T1 from today to 6 months is 6 over 12. We can do 0.5 if we want, right? Half a year. T2 is 1 year, and T3 is 1.5 years. Remember, T is always in years, so when we're talking in years, it's really nice. Right? A year from now and 1.5 years from now. And then the last thing that we're gonna do, remember the last problem we put R on each of these arrows? We don't have to do that because R is the same for all of these. And so I'm going to say that R is 0.06, right? Because assume a rate of interest of 6% for all of these calculations. Okay. Believe it or not, this is all we can have for our timeline. This is everything that we know. So what we're going to do is we're going to solve for P1 and P2 and P3, just like we would have if we had known the amounts X, right? And what we'll see is we'll get values in terms of X. Here we go. So now we solve for P1, P2, and P3 as if we know X, right? And so P1 is the future value over 1 plus RT, RT1, just being picky. The future value for all of these is going to be X, right? We don't know what X is, but we can still use it, right? So you have your future value is X over 1 plus R is 0.06 for all of these, and for P1, T was 0.5. So I have 0.06 times 0.5 plus 1. I've got X over 1.03. I could leave it like this, but thinking about X over 1.03 is not as easy as thinking about something like 2X, for example, right? And so what I want to do is I want to change the 1 over 1.03 into just one number, okay? And so what I can do is technically a multiplied fraction, so I can unmultiply them, I guess, right? I can pull them apart and rewrite this as 1 over 1.03 times X over 1. Right? We know how to multiply fractions. We multiply the top and then multiply the bottom, and then they merge together. So we could multiply this back if we had to and get this, right? But this is going to be the trick to combining this into one number that's not a fraction. And so X over 1 is just X, right? So what I can do is I can pull that X outside, deal with the 1 over 1.03. 1 over 1.03, 1 divided by 1.03 is, I can replace that with 0.970873786. And then I multiply that by X. Right. Since 1 over 1.03 is 0.970873786. You could also use the 1 over X button on your calculator if you're feeling crazy, right? If you've got 1.03 on your screen and then hit the 1 over X button, it should give you 0.970873786. Just to save you a
Sorry, can you say
two.
that again?
If you've got 1.03, so on your calculator, have 1.03 on the screen, and then hit the 1 over X button. So 1.03, 1 over X. Or you can do it 1 over 1.03, it doesn't matter, right? But sometimes, if this value is big and nasty, then you don't want to be plugging. You could store it and then do 1 over it, but then it's nice to have this 1 over X function. Okay. So usually, this is where people get lost, right? Going from here to here. So are we kind of okay with that? Or should we talk about it a little bit more? Kind of okay with that. Hey, that's great. Right? But if if you're still kind of getting set, we're going to do 2 more of these, right? So you'll have a chance to get the hang of it, right? But if it still doesn't make sense, then maybe come talk to me after class and we can just kind of sort it out. Because it is a problem that a lot of people have usually. Okay? Because I know how these problems go, I'm going to store this 0.970873786 somewhere in my calculator because I know I'm going to need it later, right? And I'm about to calculate 2 more of these, and I don't want to have to enter them all in because they're all going to be long and nasty like this. And so I'll make a little note to myself that I'm going to store this in 1. So store this in 1. Okay. How about P2? P2 behaves the same way. Future value over 1 plus RT2. Future value is X again over 1 plus 0.06 times T2, which is just 1. So we get X over 1.06. Not showing the steps, right? But still doing 1 over 1.06. Right, so 1.06, 1 over X. I get 0.943396226 X. Oh. I'm going to store this in 2. You can see how you want to be storing these because they all look very similar, right? They're slightly different, but we don't want to be entering them in manually. Okay. And then same deal for P3. P3 is the future value over 1 plus RT3, which is X over 1 plus 0.06 times 1.5. 0.06 times 1.5 is 0.09. So I get X over 1.09, which I'm going to transform into 0.917431193X. And I'm going to store this in 3. Okay. So now I know each of these values, right? I know P1 in terms of X, P2 in terms of X, and I know P3 in terms of X. So now I also know that they have to add to 10,000, right? And so what I'm going to do is I know that 10,000 has to equal P1 plus P2 plus P3. Right? So as long as I know what they have to equal, then I can solve for X. So what we have is we have 10,000, I'm going to give myself a little bit more room here. 10,000 has to be P1, but P1, remember, was, I'm going to recall 1.970873786X plus P2, which was, recall 2, 0.9433962226x plus P3, which was 0.9174311193x. Now these are just coefficients of x, right? So technically what I'm doing is I'm pulling out a common x, right? And I'm adding these all up together. And so what I've got is I can pull out the common x, and here's where I'm gonna get cheeky, because I really don't wanna write these all out again. Instead of writing 0.970873786, because I made a note earlier which spots I'm gonna store these in, right? I'm gonna write recall 1 plus recall 2 plus recall 3. You're only allowed to do that though if you've told me where you've stored stuff. But you are allowed to do that. But only if you've told me what recall 1 does, recall 2 does, and recall 3 does. So now I've got x times, and now I can just do recall 1 plus recall 2 plus recall 3, and I get 2.8317012005. Yeah. Okay, we're so close. Remember that all of this has to equal 10,000. Solving for x, then we get 10,000 divided by 2.8317012005. So x must be 10,000 divided by that previous answer, which I get 3,531.446037. But x is a dollar amount, right? So x is $3,531.45. Those are the equal payment amounts, right? So you're paying the same amount 6 months, 1 year, and 1.5 years from now, but they're all paying off different amounts of interest, right? And kind of on behalf of each other sometimes, right? The first one. All right. This is not the same as 10,000 divided by 3, right? No. So I don't want to see that because we've got interest to deal with. I think I might see that, but not from anyone here today, right? All right. I know I'm going to see that, actually, but it's okay. All right. So on test 2, there is going to be one kind of similar to that big example that we just did, but also one where you're calculating the unknown payment amounts, right, for simple interest. Okay. So be prepared to do both, right? Calculating the new total that you have to pay off, right, or some unknown payment amount. Right. Any questions about that problem? No. All right. So section 4.7, we're not going to talk about because we have really talked about it a lot, but I'm going to see the textbook for general strategies for time value of money questions. So these problems are all time value money questions, right? Because over time, the value of money changes, right? So see textbook for general strategies. For dealing with time value of money problems. I guess I shouldn't call them problems, questions. Time value money is often abbreviated TVM. So if you see, I know Khan Academy does a lot of good videos, but he'll call them TVM or time value of money questions for simple interest, right? So that's what we're doing right now. Okay, so we're not going to go through 4.7 because that's essentially what we've been doing with talking about all the timelines and how we break them down and all that fun stuff. So we're moving on to section 4.8, which is changing interest rates. A little bit different from earlier when we had first agreement was at one rate and then the second agreement was at the second rate, because the rate actually stayed the same for each agreement, right? It just changed between the agreements. And so, for example, say interest starts at 5% and increases by 1% every 4 months. What is the value of a $1,000 investment after 1 year? So we start at 5%. In the first 4 months, it's 5%. But then for the next 4 months, it's going to be 6%. And then the next 4 months, it's going to be 7%. And then the last 4 months, or maybe I exhausted. Anyways, it keeps going and going and going, right? But we want to know what's the value of a $1,000 investment after 1 year. And so we could map this out. It's going to get a little bit weird. So if we start today, and then we've got 1 year, but we're talking about months, right? So at 12 months. So we've got to take at 4 months, right? Because the interest rate is changing every 4 months. And then, so 4 months after that is 8 months. And then 4 months after that is 12 months, which is the year. So now, what we have is we have a $1,000 investment. The $1,000 is going to sit there at a rate, I'm not going to put T on here. Well, I guess I should. T1 is 4 out of 12, but also the rate is 0.05. After those 4 months, we're going to have earned some amount of interest. And here's where it gets tricky, because we want to be calculating future values and then tagging it on. But because we're talking simple interest, right? So actually what you want to be doing in your minds probably is compound interest, where we would earn interest on the interest that we've already earned, right? We would bake on that interest. And so that's what we're going to be doing with compound interest. But for now, because we're dealing with simple interest, right? Here, after 4 months, then we're going to imagine that $1,000 being reinvested for another 4 months. So T2 is 4 out of 12, and R2 is 0.06. And it's going to yield some amount of interest I2. And then at 8 months, we imagine reinvesting the $1,000. Same idea at the end of the 12 months, right, or the 12-month mark. T3 is still 4 over 12, but R3 is 0.07, right, increasing by 1% every 4 months. So then the total value is going to be P plus I1 plus I2 plus I3. Okay. We haven't used I equals PRT in a long time, right? Because we've had more sophisticated things to do with the future value formula, but we can bust it out again, right? And so we've got I1 is PRT. P is going to be 1,000 for all of these, and only the rate is going to change, right? Because the time, the increments of time are going to be the same, right? 4 over 12. And so only the rate is changing 0.05 times time, which is 4 over 12. So I get 0.05 times 4 divided by 12. And I'm just going to multiply by 1,000 right away to get $16.666 repeating. So in money, $16.67. So that's the amount of interest after the first 4 months that I've earned. After the next 4 months, I've got I2 is PRT, which is 1,000, times R, which is 0.06 now, times T, which is still 4 over 12. Oops, it's a different 4 over 12, but same either way. 0.06 times 4 divided by 12 times 1,000 is 20 even. I3 again is PRT. P is 1,000 times R, which is 0.07 now, times 4 over 12. 0.07 times 4 divided by 12 times 1,000 is 23.333 repeating. So in money, we get 23.33. Okay. If we're thinking about this, right, even though we're moving incrementally, the total value at a year from now is a future value, right? Just like the future value is P plus I, even if we're changing the interest rate, we could have the future values P plus I1 plus I2 plus I3, right? And so the future value is P plus I1 plus I2 plus I3, which is 1,000 plus I1, which was 1667, plus I2, which was 20, plus I3, which was 2333. Adding these all up, I get an even $1,060. You can do it this way, totally fine, and it actually eliminates one of the formulas that you have on your formula sheet. Or if you've got this changing interest rate, right? If you look at your formula sheet, and I've got some extras if you forgot yours, but if you look at your formula sheet, the last formula on the simple interest side of things is something that kind of looks like this, right? Where we've got R1, R2, R3, right? So we've got changing interest rates, right? Or we could use the formula for changing interest rates. Right, which is the future value. And it's going to have the same shape, let's call it, as the regular future value is P times 1 plus RT, right? But we've got P times 1 plus R1 T1 plus R2 T2 plus ... all the way up to making room for M rate changes. This is only if you've got one principal amount and it's being subjected to rate changes as you move along, right? Rate 1, rate 2, rate 3. And then you just tell it how long it was at each rate for the T's. This is on your formula sheet. It's been a while since we did that. Right, but just to highlight that that's on your formula sheet. So now, for us, we've got a future value is P times 1 plus R1 T1. And did I call them R1 and T1? I did too. Look at me go. R1 T1 plus R2 T2 plus R3 T3. We only had 3 rate changes. So that's where we go to. P, we said, was 1,000 for all of these, right? So 1,000 is our P times 1 plus 0.05 times each of these T's in this question are 4 over 12, right? But that's not always the case, right? It could have been 5% for the first 6 months, and then 6% for the next 2 months, and then 7% for the next 8 months or whatever, right? So we could have different T's. In this case, though, we don't. T1 is 4 over 12 plus R2, which is 0.06 times 4 over 12, plus R3, which is 0.07 times 4 over 12. 1,000 times, and I'm just going to simplify these as best as I can. 0.05 times 4 over 12, 0.01666 repeating. I'm actually going to store this in 1. plus 0.06 times 4 divided by 12, 0.02 plus 0.07 times 4 over 12, 0.02333 repeating. Oh. I'll store this in 2. Might get confusing, but those are just notes to myself, I guess. So now I can do 1,000 times, don't forget that 1, it's gonna make a big difference, right? 1 plus recall 1 plus 0.02 plus recall 2. All right, so plus 0.02 plus recall 1 plus 1. I get 1 nicely condenses to 1.06. It wouldn't have done that unless you kept all your decimal places, right? And so that's why you have to keep all your decimal places until the very end. But now 1,000 times 1.06, we get, not surprisingly, the same answer that we did before. Right, we're finding the same thing, just 2 different ways of doing it. If you want to do it the first way that we did it, right, where you're highlighting each of the amounts of interest and completely forget about this last formula on your formula sheet, that's totally fine, right? But sometimes the formula is a little bit easier to deal with. Right? All right, any questions? Then let's leave compound interest for next day because I've worked too hard enough. And then we'll start fresh next day with compound interest in chapter 5. All right. See you guys on Thursday, I guess. Time flies when you're having fun.